The recent discovery of potential life signs on K2-18b, a planet nearly 3 times Earth's size, 124 light-years away, marks a thrilling moment in our search for extraterrestrial life. Let's switch gears here, because last week scientists announced the strongest evidence yet of life on another planet. To explore this topic and the next steps in our search for alien life, we're joined now by Ricardo Ogando, an astronomer from the National Observatory. K2-18b is what we call a sub-Neptune planet. It's a bit bigger than Earth, but smaller than Neptune and has long been on scientists' radar. In April 2025, Cambridge University researchers detected molecules on K2-18b that, on Earth, are only produced by living organisms. We've discussed this before, and you can find the link to the study in the description. Researchers consider K2-18b's evidence the strongest yet for possible alien life, making us wonder what life might share our universe on distant worlds. Earth's story began 4.6 billion years ago as a hostile place, with intense volcanic activity and frequent meteor impacts. Only after Earth's crust cooled and the first oceans formed did conditions emerge for life to appear. Our current era is just 12% of Earth's history, yet it's seen complex life explode from dinosaurs to humans, who appeared a mere 300,000 years ago. A mere blink in Earth's geological timeline. The evolution of processes like photosynthesis transformed our planet, enabling oxygen buildup and the rise of complex life forms. These processes aren't unique to Earth. They're universal, potentially occurring on any planet with similar conditions. K2-18b seems to show this complex process might be happening everywhere, suggesting half the stars we see could host life. This puts us humans in the Milky Way in an incredible yet frightening and haunting situation. We long believed intelligent life would be extremely rare in the universe. Recent studies suggest life's emergence might be a natural process, not an extraordinary event as we once thought. Given the right conditions, life can emerge and evolve much like it did on Earth. This means if we find planets similar to ours, there's a real chance of discovering life on them. This perspective shift drove scientists to search for habitable worlds beyond our solar system. Life on Earth evolved following the laws of chemistry and physics. We can assume this process could occur elsewhere, as nature's laws are universal. Carbon chemistry works the same here as it does millions of light-years away. Elements like hydrogen, oxygen, carbon, phosphorus, and sulfur exist throughout the universe. If life arose here, why not in other places with similar conditions? This suggests life might be common in the galaxy, not an exception. To grasp this discovery's significance, we must understand cosmic distance scales. Our solar system, with 8 planets, dwarf planets, and smaller bodies, spans several light hours. This method simplifies distances between celestial bodies in space. It represents the distance light travels in a vacuum over a specific time. A light minute is 18 million kilometers, while a light hour is about 1.08 billion kilometers. Sunlight takes 4.3 hours to reach Neptune, and our entire solar system spans 22 light hours. Outside our solar system, the closest star, Proxima Centauri, is about 4.3 light-years away. This means light from that star, traveling at 300,000 kilometers per second, the speed of light, takes 4.3 years to reach us. Expanding our view a bit further, we're still in our immediate stellar neighborhood. This area spans about 50 light-years around the Sun and includes several dozen stars. The galactic neighborhood extends thousands of light-years, encompassing the entire local arm of the Milky Way where we're located. In this context, K2-18b, 124 light-years away in Leo, is relatively close galactically, though beyond our immediate solar vicinity. So we can think of it as a neighbor not on our block but in our cosmic community. This intriguing world has 8.6 times Earth's mass and is 2.6 times wider than our planet. In 2019, scientists found water vapor in this planet's atmosphere, drawing attention to the system. In 2023, the James Webb Space Telescope detected carbon dioxide and methane in its atmosphere. This marked the first time carbon-based molecules were found on a planet in a star's habitable zone. These findings already made this planet an intriguing target for habitability studies. The big breakthrough came in April 2025, when Cambridge researchers again detected DMS and for the first time DMDS. On Earth, these substances are produced only by living organisms, mainly simple ones like marine phytoplankton. Thus, these compounds are potential biosignatures, chemical signals that might indicate the presence of life. K2-18b is an ice-in world, a planet with liquid oceans and hydrogen-rich atmospheres ideal for microbial life. The DMS and DMDS levels found there dwarf those on Earth, making our planet's concentration seem insignificant. With over 10 parts per million by volume, this finding becomes even more fascinating. In November 2024, researchers found DMS in a comet, suggesting a new, non-life-dependent production method. This raised the possibility that comets brought DMS to the planet. However, the high concentration detected makes this explanation highly unlikely.
So Ricardo, let's compare. What evidence did we have before and how has it changed? As you just pointed out, it's important we emphasize this. We're talking about a different type of life on that planet, not like what we know here on Earth. Yeah, we have no clue what kind of life might be there, right? The evidence is always indirect. On Mars, we send probes often to find signs of water or geological markers indicating past life. We believe some moons in our solar system might host life. Probes are planned to study places like Jupiter's moon Europa. Recently, in early 2020, we observed phosphine, a phosphorus-based element on Venus. Yeah, this result was also hailed as a major breakthrough at the time, wasn't it? It fit with various models of life existing, even suggesting life on Venus, but the scientific community strongly rejected it because, and Venus is the morning star, right? Yeah, it's a planet right next door, but it's incredibly hard to analyze. Despite being so close, it's got a really hostile environment. It's tough to say if there's life there. Now, these exoplanets, we found thousands in recent years. We know there's a ton of them scattered across the galaxy. What we measure, and this particular planet we're talking about, K2-18b, it's in what we call the habitable zone. That's where liquid water can exist, which, as far as we know, is the key ingredient for life as we understand it, right? That's why everyone's interested in this planet and discovering biosignatures. All the evidence is indirect, and we can't yet say for certain, there's some kind of life, microbial or otherwise, on another planet. But it's a big step forward. As you said, science progresses bit by bit, and we celebrate each advance. However, if these traces are indeed life, it puts Earth's existence in a new, unsettling perspective. If life is common in the universe, where are all the advanced civilizations? This question, known as the Fermi paradox, has puzzled scientists for decades. One explanation involves the Great Filter, a tough evolutionary hurdle that stops most species from reaching advanced technological stages. This filter could be in our past, meaning complex or intelligent life is rare, and we've already overcome this barrier. Or the filter could be in our future, suggesting advanced civilizations self-destruct before colonizing other star systems. Finding microbial life on K2-18b wouldn't directly answer this, but it'd hint at how common simple life is, its limits, and traces of those that crossed barriers. As technology advances, comparing life there to life here could prove panspermia-related theories. The idea that life can spread from one planet to another, possibly via meteorites. However, this theory faces major physical limits like genetic material decay in space due to radiation and time. Previous studies found DNA has a shelf life of only 521 years under normal Earth conditions. This is because after cell death, enzymes in cells start breaking bonds that form DNA's backbone. Even in ideal conditions like amber preservation, DNA would degrade after 1.5 million years and be gone in 6.8 million. This finding not only rules out dinosaur cloning fantasies, but also limits the idea of life easily spreading between distant star systems. Besides genetic decay, vast interstellar distances are another hurdle for life's natural spread. The fastest human-made probe travels at about 21 kilometers per s, far from light speed of 300,000 kilometers per s. At this speed, reaching Proxima Centauri, our nearest star, would take about 73,000 years. To reach K2-18b, 124 light-years away, would take millions of years, far beyond DNA's survival time in space. These limits suggest life spreading between stars needs extreme protection or advanced civilization's intervention. Given these barriers, life on K2-18b, if confirmed, likely evolved independently, mirroring Earth's chemical and biological processes. But if it's Earth-like, it suggests something astounding. Someone brought it there from here in the distant past. And this someone surely possesses the knowledge to overcome these vast distances. As we explore our solar system, a new concern emerges, potentially contaminating other worlds with Earth's microbes. Despite strict protocols, our probes and rovers might carry extreme conditions surviving bacteria to other planets and moons. This accidental panspermia
It could compromise future searches for alien life, as it'd be hard to distinguish between native life and Earth contaminants. Space agencies, aware of this risk, try to minimize it. As Mars mission plans advance, avoiding contamination becomes trickier since humans carry trillions of microbes. This could be a pattern for any life that naturally evolved. Interestingly, K2-18 is a red dwarf, smaller and dimmer than the Sun, but with a much longer lifespan. While the Sun will live about 10 billion years, now at 4.6 billion, red dwarfs can last trillions of years. If life arose on K2-18b, it may have had much more time to evolve than Earth life. Age estimates for this star range from 1 to 10 billion years. If it's closer to the lower end, life there is likely just bacterial. But the DMS and DMDS levels are so high that, at the upper limit, life there might predate Earth's by billions of years. Some species may have evolved far beyond what we know in entirely new ways, given this unprecedented gas concentration. However, it's crucial to note that evolution doesn't always lead to intelligence. The unique conditions of each world shape the evolutionary paths life takes. In the coming years, even more powerful telescopes will begin operating. The Extremely Large Telescope, or ELT, with its 39-meter main mirror, will observe exoplanet atmospheres in unprecedented detail. The project, about 60% complete, aims to be one of the most advanced astronomical observatories ever built. Its goal: find evidence of potential life on exoplanets and glimpse the universe's first stars and galaxies. The $1.5 billion telescope is a project of the European Southern Observatory, an intergovernmental research group. It's located in Chile's Atacama Desert, one of the world's best spots for astronomy. It will impact virtually every area of astronomy. We'll see how the first galaxies and stars formed in the early universe. We'll be able to see stars and galaxies in incredible detail. Plus, we'll make huge progress in understanding worlds around other stars. New methods are being developed to better detect biosignatures from afar. One is direct imaging of exoplanets using devices that block starlight. Though we can't visit these worlds soon, we can learn lots by observing them. Future telescopes will detect biosignatures and map exoplanet surfaces. This info will help us paint a fuller picture of potentially habitable worlds in our galaxy. Even if K2-18b only hosts simple microbes, it'd suggest life is common, not a rare exception. This would make us rethink our assumptions about how frequent and widespread life is in the universe. If life arose on two nearby planets independently, there could be billions of habitable worlds in our galaxy alone. Many Earth-like planets have been found by AI, which we'll discuss next week.